Hello, hello. I'm not sure if the sound is on. Okay, so hello everybody. Hope you can hear my voice. This is the 30-second Houdini tutorial live that I'm doing weekly. And the topic today is to create this kind of line flow network, line growth, using a shortest path method. And I think it's going to be really easy this time for this week, since there's not going to be much coding needed for today's work that I'm going to do. So yeah, it's going to be pretty easy. And by using this, you can create this kind of smooth animations by also changing the geometry as well. Could also work for any kind of geometries, like big head or torus or anything. And you can also kind of change the way how this line flow animate or growth on top of the geometry by changing the weight function or cost function on top of each point, so that you can kind of control how these flow works. Okay, and well, but that is pretty easy. I mean, that is pretty simple to do. So let me show you how. And hopefully I can finish this less than an hour for today. Right, let's do this. Low. Okay, so I am going to create a geometry node from scratch. Hello everybody. And let's start by creating a null node, so that I will store all the parameters that I want to use to control. Now let's give several kind of geometries like sphere, torus, and big head, so that we can change the geometry later on. Now let's also define the size, and for the spheres I'm going to change this to a polygon. And since I am going to use a shortest path node, it works on the edges of the mesh. So more edges you have, more density you could get. So I'm gonna make the frequency for the sphere a bit bigger, like 15. And for the torus, I'm gonna make the resolutions to something like this, maybe 50 to 100. That might be too much, not sure. Or maybe I can do a remesh to create a triangular network like these with the target size of 0.1. That might be good. Okay, and for the pig head, maybe I can also do the remesh, or maybe I can just use this as it is, but let's try with the remesh. Alright, so let's try with these geometries. I am going to use a switch node so that I can switch those geometry with some parameters. So for this select input parameters, I want to make a parameter from 0 to 2. So let's create that first into a node controller. I am going to create an integer. Let's say I'm going to name this shape. The range from 0 to 2. Let's copy this, then paste it right here. Okay, now I can change the shapes. Now, next things that I want to do is to create, well, let's first set a normal node to calculate the normal for the points just in case. And what I want to do next is to define the starting point for the flow to start the growth. So it could be anywhere, but what I'm going to do is to create a add node, which then I can control and add 1 point by checking it. Then I'm going to use the arrow to define the position by myself manually. But as you can see, the point is currently not on the geometry, so I want to make this point attached or cohere to this base geometry. So I will use the array node to do that. So this is the point that I'm going to project. This is the base geometry, and I am just going to use the minimal distance. Right. Or maybe I can just use point wrangle instead of using this array, using a new point. Maybe that might be better. Okay, so let me do that way. I am going to create a attribute node, attribute wrangle, and say set the name of this wrangle to set start. Okay, and I'm going, since there is only 1 point that I want to move, I am going to set it as detail, and I'm going to connect this starting point, the guide for the starting point, in the second input, like this. Okay, now first of all, I'm going to retrieve the point position from the second input, which currently you only have 1 point. So I can get it from the second input, p at index 0. Right now, now I can calculate the near point number from a base geometry, which vertices on the geometry is close to this point that I have added manually by using new point with this position that I have retrieved from the second input. Then let's store this number into a detail wrangle. Maybe to specify which point is chosen, maybe I will set the color for this point to something obvious. So maybe something like red. So I'm gonna say set point attriv cd npt set 1 0 0. Okay, now where is that? Okay, so here it is. So this point will be the starting point for the shortest path growth will happen. Right. Now let me just connect this to a null node first. Let's just name this geo. Okay, and then I am going to use this find shortest path. Okay, now the find shortest path is itself is a really strong node. Can do what it can do is to find out the shortest path between the selected starting point and selected end point, and using this edges on the mesh. Right, and what I'm going to do is to create the shortest path for every vertices exist in this mesh from the starting point, so that the geometry will be covered by all those shortest paths. Okay, so that's what I'm going to do. So to do that, first thing that I have to do is to change the option for this output path. Currently it says from each start to any end, but I am going to say from any start to each end, which will be able to create a multiple curves from a single point to every endpoint. And right here I need to define which point will be the starting point and which point will be the end point. So for the starting point, which is this one, you can access to this point number by going to the detail attribute, which I have stored an attribute for the starting point, which is called NPT. So this NPT value is the actual number of this point, I think. If I show up the numbers, yeah, I think it is. So I can use this number for the starting point, for the shortest path, and for the end points, I am going to define all the exist point number in for this geometry. Okay, so for the first one, I can access to the detail wrangle, so detail attributes. So what I'm going to do is to first use the back bracket, back, how do I say, back some quotation, back quotation, and then inside I'm going to write an expression to access to the detail, and I am going to access to this null geometry, null node detail attribute. So I'm going to name use geo, then access to the attribute name npt, and for the first value, so it's going to be 0. So as a result, this should convert the value into this number, point number. Now for the endpoint, I'm just going to type this star mark right here, which will create a all the shortest paths from the starting point to each end point, each vertices, which will create this kind of a blocky path. Still looks interesting, but the base things that I'm going to deal with, right? And you can kind of change the path based on how you define the edges. So if you do the remesh for this one, you can also kind of see some different results. Let me try that. And as a result, you'll see a bit more jagged line. Without it, you see a bit more cleaner line. Let's see for the other shapes. For the torus, it looks like these. With the remesh, without the remesh, it looks like these more straight based lines. But for this one, I think I like the remesh version. Well, let's also see the pig head. Now for the pig head, it looks like a tree vine. Now if I disable the remesh, it looks more like a Tron-like path, right? Okay, so but I guess I like the remesh version better, so I'm gonna go like this. Now the next thing I'm gonna do, it's pretty simple. I'm just going to smooth this curve out using smooth node, and I would like to control the smoothness for this curve, so let me have some parameters for that one. I'm going to open up the edit parameter interface again, uncheck for a bit linking, then go to the smoothness and drag and drop the one that I want to promote, and I'm going to change this to smooth. Let's say the maximum be 100. Okay, and let me also change the shape back to the sphere. And let's try to see the changes by raising up the smooth. So starting from 0, starts to create something really beautiful like this. Okay, so now this itself is already, I mean, almost close to the complete thing, completed things that I am seeking for. What I'm going to do next is to make sure that these curves are on top of the base geometry. I'm going to use the ray node again for these curves to the geometry with a shortest distance, a minimum distance option. Now those curves are all going to be on top of the geometry, just to make sure that curves are not offsetted inside or outside the geometry, but that might not be necessary as well. Okay, so, and I'm going to connect the Null node. Let's name this well, maybe anything. Geo2 is fine. Okay, and final thing that I want to do is to create some animations so that it looks like it's growing from the starting point to the end point of this for each curve. And the easiest way that I could think of is to use a carve node. And for this one, I'm going to try to see which one does which. So I have enabled both U and V, and okay, I'm seeing a bit weird result. Okay, now it looks good. So if I enable first U and second U, and if I change the first U to 0, and if I move the slider for the second U from 0 to 1, it will create a growth-like line flow, like I want it. So let's try to change this procedurally based on the frame value. So I'm gonna set the end frame to something like 100, then change the second U to, with the expression, the current frame divided by the frame end value. As a result, you'll be able to create a value from 0 to 1 based on the frames, and you can create this kind of animation pretty easily. Alright, now as an additional things I can do to this geometry, currently if I set up the starting point for the sphere, all the endpoint will be at one point, which will be the backside of this sphere, right? That's pretty obvious, but that is because it is using the distance distance as a path cost, and so the speed of the path will be always the same for each every path. But by changing the cost or weight on top of the geometry that I'm working with, you can kind of change the path itself. Say currently the path weight is equal to 1 for every point on a geometry. Like if you look at this, currently the default value for each point, each vertices on the mesh that I have provided is equal to 1. So as a result, the actual cost that's going to be used for the shortest path is just the distance. But you can add additional weight to each of the point to make some of the path go slowly than other areas. So say this area has some mud areas which will prevent the path to go at the same speed it goes slower, so the path try to find out the path will try to duck or try to prevent going through this mud space to reach to the end of the point in a more quick way, in a shortest distance, in a shortest time or shortest cost. So by changing some of the weight values on top of the geometry, you can kind of change the flow, the type of the flow or shape of the flow curves. So let's also try to do that, and let's try to see what kind of results we get by doing it. And what I'm going to do is to use a noise function to apply some weight value in each vertices for this mesh. So I'm going to use point wrangle, and let's name this weight, and it can be just a simple functions. I'm first going to calculate the noise value, and I'm gonna name this weight using noise with the add p as a parameter. And let's also have some additional parameter in order to control the scale of the noise parameter, right? And it might be better if I change the ratio, if the range of this scale from 0 to 10. Okay, and let's also visualize how it looks like by changing this scale value at each point. So I'm going to update the color of this mesh of each point by using this noise value. Okay, so to do that, I am going to just multiply CD by weight. Which will give you this kind of black and white noise image. Now let's also look at the range of the noise value, and I think I forgot to put it as an attribute, so I'm going to put this value, the weight value, as an attribute called weight, like this. Oops. And let me also save this somewhere. And check the value. Okay, so this value is in between 0.83 to 0.2. So I think I could also clamp this value a little bit. Like it never reaches to 0, it never reaches to 1. So to make sure that you have at least at some point you have 0, at least some point you have 1, I am going to clamp this value a little bit. So to do that, I am going to use clamp for the weight, and let's say the minimum 0.3 and maximum 0.7. And after that, I am going to use the fit function for the weight so that the range will become from 0 to 1 again. Now the contrast will be more obvious. Alright, now let's see how it looks. Let's try to use this weight value as a cost for the find shortest path. So more cost you have, the more weight you have, the speed of the shortest path will be slower. I mean the distance will be longer, so the shortest path will try to prevent going through that edge or try to go through that points. If the weight is smaller, then the shortest path will try to go through that point. meaning that if the cost is less than the distance is short. Okay, so keep that in mind, and I am going to use that weight attribute by going into the path cost tab for the find shortest path. Then I am going to enable this point cost attribute and use weight. Okay, now let's look at the result. Now currently the weight value is 0 because I have scale 0, but if I increase this value, you see that somehow the shortest path flow changes based on the noise value on top of the point. It makes something a bit more organic. Right, and the animation still works. Oops, not for this one, but this one. Like this. Yep. And if I make the scale really big, it becomes more randomish network. Create like a river-like network. Right, so that's kind of pretty much it. 30 minutes. It's pretty fast. So that's the things that I wanted to show you today. Not much things to say for this one because it's pretty easy to create. Let me just promote the parameter for the noise scale. And that is pretty much it. So, I mean, you can end watching this live at this point since I have already finished it. I have already uploaded the files to the video description page on the YouTube. So if you're interested, you can download the files from there. And yeah. Well, if you have some more time, well, maybe I can try to do a similar things for the carve node with a primitive wrangle. Is it difficult to make it crawl like a snake? Let me see. I think it's doable. It's just a matter of how to control the weight on top of the geometry that you're using. So for the crawling, maybe you can use like a sine wave functions to apply a sine like wavy and weight functions on top of the sphere to create a snake crawling like pattern. Maybe I can try that. I mean, it's just a matter of changing the weight, so let's try that out. So what we can do, what will be the best way to do that? Let me see. Well, let's say that you already have the starting point somewhere, which in this case, where was it? This one. Okay, so from this point, let's try to make like a wavy weight value. Okay, so to do that, what will be the best way? Alright, maybe I can calculate the angle from this point to each of those vertices. Sine with surface distance, that could probably work. Yeah. let me check. Let's try with that. Let's try with that. So okay, so let me and comment. Surface distance, and the parameter that I'm going to use is I don't need a PT group. Let me go to the Vex function page to see what kind of parameters that I can use. Okay, well, geometry, PT group, attribute, search PT. Okay, let me give a space right here. Let me just first calculate the distance for each point from the starting point. So first thing, I'm going to retrieve the starting point number from the detail. Okay, and let's also get the starting position. At the point, then let's calculate the distance from that point. 0, PT group. Well, I'll just say empty to apply for everything, or just say use this one. Okay, and then our PT num is ordered from the origin point. Maybe it's easier than surface distance. Well, if you do remesh, I think it's not going to be ordered, so probably it's better using surface distance instead. And closest PT is the output. Okay, so which I might not need it, but I have to provide it. So into CPT. Okay, let's see. And use that distance. Well, I'm not sure what the metric is right now, so let's just try directly with the sign. And maybe multiply by pi. Okay, and that will be value from -1 to 1. So okay, let's create an absolute value of that sign value, and then apply to the weight. And let's look at the color. Well, okay, now I have a problem. That is because I didn't create the role. For this one, I think I'm missing something. Okay, so first one is 0, second was string, third one is also string. Okay, I was missing, I think I was missing one more parameter, which is this one, SPT, I think. Search point, returns distance from the search point to the closest point in the wait. Wait, maybe not. Yeah, I think I'm doing it wrong. I am doing it wrong. What I have to do is to say, well, SPT is correct for this one, but I have to change this to a current number. So maybe I should use a current number for this one, but I don't think I can use ptnum, so I'm going to name it as id, and I'm going to create another attribute beforehand using point wrangle. Okay, and then what else do I need? What it's saying: no matching functions for float, surface distance, integer, string, string, integer, integer. Is it? Oh yeah, I was missing this one, which is the method to use measure distance, accept values are edge and surface. Edge distance is measured along the edge to model, while surface is measured across a single polygon. Well, let's try to choose surface then. Okay, and how's this? Now it looks all black. Let's look at the weight value. Now it is all equal to 0, close to 0, so something, it must be wrong. Maybe the things that I wrote right here might be wrong. Okay, let me change this to something different, like random numbers, to see if you can change the value. Okay, it is changing, so kind of obvious that it is not, this one is not retrieving the ID value right here that I have created for each point, which is this one. Or maybe I can just say I2A ptnum. Yeah, that might work. Okay, now I am having some calculation time. Well, it's not like, it doesn't look like what I intended to have. What if I don't have an absolute? Well, I guess it's the same. Yeah, I guess it's not really what I wanted. Let me look at the comment. So I have to make a Weblike Growth effect at work. I thought find show this path was the way to go. Any tip to make a Weblike Growth effect at work? Well, if you're talking about the spider web like network, I have tried creating it using a pop grains before, and I have uploaded the files for that as well. So you can search for that. I think if you search for spider web with Houdini, I think you'll be able to find that. Thank you, Kara Spike, for your comment. Okay, well, let me see what I can do with this one. Maybe I will try to use the other method by calculating the angle from this point to each vertices. Yeah, let me try that way. Okay, so to do that, I'm just gonna leave this as it is and create a new weight path. Okay, I have a question. How much time does it take to learn Vex? I spent at least a year to learn how to write Vex code, at least for my needs. It took me a while because the syntax is a bit special because it's based, I think it's based on the shader based coding. It was pretty new to me. So if you already have some ideas about shader programming, I think you can do it in less time. If you don't, maybe it takes more time. Takes exactly 1 month and 2 weeks. So Daniel is really fluent at Vex, and he made it in 1 month and 2 weeks. So if you, some people are really good enough to know how to write it in really short time. But it took me a while to learn Vex. Okay, what was I? What was I trying to do? First, I'm trying to get the detail value from as a starting point. Then the next thing I would like to do is to get the normal direction stored in that point. So get the normal at SPT. Alright, then next I would like to calculate the angle for each point. So to do that, I am going to retrieve the vector direction between the current point minus the point at the starting point. So spos is equal to 0.0 p spt. Okay, so spos, and let's normalize this. Alright, and then now I have two vectors. One is this one and one is this one. Let's calculate the cross vector. So cross product using cross function between normal and direction. So you'll be able to get the perpendicular directional values to the normal and the direction. Now what you can do with it, next thing I would like to do is to probably use maybe it's a bit of too much of coding, but I can use this dihedral functions to remap or rotate this cross vector to lay out on the z plane. So let me do that. How do I do this? So I need to create a rotational matrix using this one. So is dihedral. So I want to map the normal to set 1, 0, 1 and use that rotation matrix to rotate the cross vector like this. Now I can calculate the angle from this cross vector by retrieving the calculating the a10 for cross vector z and cross vector x. The angle should be in between minus pi to pi, which means minus 180 degrees to 180 degrees. And now I can use that value to create a sine wave, I guess. Or, well, let's try to do that. So, float sine wave, sine value, sine ang, and maybe I can multiply it with some multiplication of 2 to control the number of waves. And now that I have a value in between -1 to 1, what I can do now is to get the absolute value. Okay, and then store that, multiply color with this S-file to show up. Okay, doesn't work. Doesn't really give me value that I want. Let's see. Let me also promote that to the weight. Okay, everything is 0. Okay, let me see why is that. That is because this value is 0. Alright, now I see some watermelon. And what I want to do next is to, probably based on the distance from the point to each point, maybe I can shift those to left or right. Right, so let's have that as well. Just the surface distance seems to be really expensive, so I'm just going to calculate the linear distance between the point. Say so distance between the current point and the S-pass, and let's see, use this as a shifting value. So I gotta have to change this to an angle. How do I do that? Float. Well, let me just bring this up to somewhere around here. Then let's add this distance by some pi and see how it works. Okay, now let's also have some multiplication value. Shift. Did I close it off? Okay. And let's also increase the range. Oops. Let's also increase the range of this shift from 0 to 10 to see the result. Okay, now I see something interesting, but maybe there's too much wave. Now that's too spiral. Well, that could be interesting, so let me try with this to see what kind of pattern we'll get. And well, it's not a snake-like corral, but it's more like a spiral-like network, but still looks interesting. Alright, now probably I can, to create the snake-like stuff, I think I can use the sign for this distance value and use that as an angle shift right here. So let's try with this one and see the result. And let me try to see what will be the better range for this one. Multiply by pi. Okay, that might be too much. It's okay. Well, it started to give me something what I would like. All right. Now I might need a bit more multiplication to this one. All right, looking good, looking good. Looks start to look good. Okay. Interesting, interesting. Now let's see how it looks like. Well, not too obvious. Maybe I can make it a bit more obvious. By making this value more shifted. And maybe I can also control the the range of the value in between 0 to 1 for the weight value right here. So to do that, it might be a good idea to use the ramp node, ramp parameter. So I am going to update this weight using ch ramp named as ramp with the weight value weight. And let's see, make this B-spline, make this B-spline. Okay, it doesn't seem to change. Am I doing it correct? Okay, I think I need to multiply this one to right here. Okay, this seems to make a bit more obvious patterns. Let's see. Well, it looks okay. Well, still, it's a bit interesting. Maybe increasing the resolution and reduce the number of curves. Probably, we could try that. To increase the resolution, we can raise up this one. Oops. And currently I'm using all the points right now because of this one, but I can pick up the point randomly where to connect by, let's say, create another point wrangle. Let's name this pick end, and set the group for the point that I want to use for the endpoint. So if random some threshold, then set point group end. Okay, and should be at P. Okay, so let's say if I am going to use like 30% of the endpoint as an endpoint. Now to do that, I can go to the shortest point and use end instead of this one. Now the result will be, let's just look at the result by going to the end frame. Yeah. Let's try to control the threshold right here to 10%. All right. Interesting. Yeah. So you can control a bunch of stuffs by like controlling the weight value or changing the starting point, end point, and so on. Maybe the change in the weight is really interesting. I mean, because there's a lot of ways to do that. Not limited to what I have shown, but probably many ways. But just to make the curves organic in a pretty way, maybe using a noise is always a good start, because it's pretty. If you try to make it artificial, it looks artificial. So maybe I might need some some noise value to this one as well to make it a bit more organic, if you want it. Okay, well, let's try to see this with other shapes to see how it looks like. So this one, for this one, it's not really obvious that I am making like a crow-like shape. That is because it looks like these. Right. So, yeah, that was the optional stuff. It looks so simple looking at you typing what you're reflecting for the problem solving. Thank you for sharing. Well, thank you for your comment. Well, I'm doing this kind of things in daily basis recently, so I get used to thinking in geometrical way. I guess that's why. Especially I'm using the Houdini as a main tool currently for doing any kind of geometrical operations, so yeah, I really love this tool. Right, now let me promote this threshold value as well. It's a good parameter. Maybe I can also switch the type of weight between the noise and the sine wave based. Okay, I am going to upload this file after I have finished the streaming, so if you have interested, you can go to the same web page to download the file. Did they mention some web server API on 15.8's presentation? I think they have listed the function for web server API on the presentation, but I didn't really hear the detail about it. But it sounds really exciting. We could do that. If we could access to this kind of geometrical like functions through a web API, that would be really great. That means we can create a web app with this kind of like expensive, rich functional geometrical functions. Now that is a lot of possibilities. All right. Now, what I wanted to try previously, but which I couldn't do on time, is to create this kind of animation without using carve, since the carve just create the animation from the 0 distance to the maximum distance for each primitive at the same time, but I wanted to change the scaling timing for each primitive for each polyline to be defined by the length of each polyline. So if there is a short distance, a short length polyline, I want to make that curve to be grown fast, and if there's a longer version, a longer polyline, that I wanted to make those polyline in with longer time but carve wouldn't let you do that because it will just, you just have to define the UMV. And I cannot access to the primitive number inside this expressions using the carve. So, and I found out that I found out in some I think it was in the Oddforce forum where people are posting the way to create a network. I mean, controlling the length of the primitive by using some Vex function, by importing some library or something. But it didn't also work for me because when I used it, what it's just doing is to just trimming each control points of the primitive one by one, so the animation doesn't really look smooth. Let me search for what I have. What was that? I think it's in the history somewhere. Let me see. I think it's this page. So there was a suggestion to use this function, and the function itself works but doesn't really give me a pretty result. Maybe I can show you that. So instead of using carve, I can use a primitive wrangle. And okay, using this one, and let's change this distance to frame value, which I can calculate it by the current frame divided by the f, and I also need to measure the parameter for each polyline like this. And am I missing something else? Okay, I think it works. Now if I look at it, now I also need to delete fuse the unused point as well. Now let's see the animations. It looks like now it might not look that bad. Wait, doesn't look like what I am seeing last time. Looks smoother than the last time I saw it. Well, maybe this works. Maybe using this might work. So how can we get the shortest path through point cloud if we want to make the growth inside a volume instead of geometry? How can we get the shortest path through point cloud if we want to make the growth inside volume instead of geometry? Well, the shortest path wouldn't work for volumes, so I guess you cannot use this node, because the shortest path only works for the connected networks, I think, using the graph theory. So if you want to make the similar kind of shortest path using the volume, you have to make you first have to make a network using the point cloud inside a volume or something. And making that kind of network might be really expensive. So yeah, I guess but that I think that's the only way I can think of in order to create a shortest path for the point cloud. First you need to create a bunch of networks connecting each point then do the similar calculations that's done right here and define shortest path. Maybe you can just use this as it is. I mean, if you have a sphere, if you get the volume, if you get the scatter point, in order to calculate the shortest path, you need to have a curve network going through all the points. So first thing you have to do is to create a curve network. And to create a curve network out of this point, I guess there are several algorithms to do that. I'm not sure what will be the best way to do that. One way you could think of is to use just the point wrangle and search for some closest points in some distance. With some, so let me check the parameter. Okay, so 0, p, and let's say search, and connect all those points together using a curve. Now you'll be able to get a duplicated line, so we're going to remove the duplicated later on, and that's the reason why this might not be a really effective way to create the point. You can get the near point positions, and then calculate the distance. And if the distance is less than, I mean, I don't need this. I mean, I didn't need the distance as well. I just need to create the lines. Add trim, polyline, and pt num to npt, and I didn't need the position as well. And raise up the search distance. Okay, doesn't make anything. Alright. Am I missing something? Okay, polyline, ptnum, and pt for loop argument. Oh yeah. Stupid. Sorry. I was looping through a 0. Okay, now it's too big. Now you might gonna need to make this kind of curve network. And then remove the duplicated lines using convert line, which will be the easiest way to do. So currently I have like 10,000 primitives. If I remove the duplicated lines, it will become half of the lines, half of the lines. Now I guess I can connect this to a, let's say, try to replace this with the sphere right here. So if I change the shape value to 3, and if I look at the result, what could that be? Now I think I'm looking at the cache. Well, it looks more like Well, it doesn't look like anything. It looks like a hair. But that's actually how you could, I guess you could calculate the shortest distance for the point cloud. So, well, that's probably it. There might be a better way to deal with this kind of point cloud. Not sure what will be the best way. But yeah, it's an interesting topic. Okay. So this seems to work well, so I think I've kind of satisfied myself experimenting all this stuff with you guys. Thank you for sharing your knowledge and questions. Okay, now I think it's a good time to finish. Any way to make secondary growth lines from that? So maybe you're mentioning maybe at some point create another lines from some of the point. I guess you could do that maybe using conditions or for loop. This is when you have completed the shortest path, the first shortest path from here. Let me see. Let me think. Well, let's say you are picking the half of the point as an endpoint. That means some of the point is not being used as an endpoint, so we can use that as a second endpoint. Needs to reduce the line count first. Yeah, there's too much lines right now. Like these. Maybe from here we could try a secondary line for some of the curve. Okay, so for these, well, to avoid the collision, that might be too hard, so I'm going to ignore that. So be minded that there's going to be a collision between curves and curves. To prevent that, I think you need a complex conditions. But if you can accept the collisions, what you can do is, well, at this point, let me see if there's enough information for those points. Maybe not. Okay, so the number of points that I get from here and the points right here is different, obviously. Now, what will be the best way? Maybe the shortest path to the closest point on the primary lines. Shortest path to the closest point on the primary line. Shortest path to the closest point on the primary line. That might be interesting. Yeah. Sounds like it's going to connect line to line. I'm not sure. Let me try. So first I'm going to retrieve some of the point from the curve that is being created, which is this one. Or just before doing the smooth might be okay if I'm using the same point. Okay, so let's do that by using primitive wrangle, access into some of the primitives. Maybe it needs another threshold with some seed value. I'm just gonna make it constant seed and rand. Threshold. Okay, and let's say 20%. And I'm going to get some point at the primitive. Maybe I can retrieve the center point or something. And let's see how I can retrieve the position on the point, the primitive, instead of just getting the point number. I think I can use some UV related functions. Let me check. Let's say UV sample. Oops, no. UV sample interpolates the value and an attribute certain UV coordinates to UV. This might work. Geometry, attribute name, UVW. Let's see. Attribute name, UV name. No, well, I think I also need to. I think this one works. Let's try. So, integer. I mean, what I want is the vector position using UV sample 0. The primitive group is A2I, or I mean I2A prim num, and the attribute name is P, and the UV attribute, I didn't have a UV. Alright, well, that will be the problem. Okay, I didn't have a UV value, so to get that, maybe I can do the resample. And make the maximum length segment, or just set the segment to small values like these might be, that's fine. And also check curve U. This will be the UV value that I could use. Okay, and for the UV value, UV attribute name. Wait, attribute name is the one that I want to get, right? And the UV attribute name. The name of the point of vertex attribute contain UVs. The default UVs created into the name attributes. Reach sample the attribute. Okay, so first I need to retrieve the curve U value and set it as a UV value. I'm just gonna update U, and then use UV, and the one that I want to search for is 0.50 0, which is going to be the half of the primitive, I hope, hopefully. And let's check that out if I'm getting the point that I want. By setting the color to red. Okay, set point pt. Okay, some of the point is at the end, so I think it's wrong. Let's just retrieve one of the primitive. And where did that point go, the red point? I think I'm not seeing it. Where is that? Okay, let's check if the point has been changed. 28, 20. Okay, so no points being added. I think I need to make this available. 28, 29. So somewhere the point has been created, but I am not sure where that is. Is it at the end? Okay, let me just delete the primitive then. Oops, what's this? Okay, I don't see. Ah, so here's the point that I was looking for. And before deleting, now, well, it doesn't look like it's in the halfway distance. So, yes, the way that I wrote is obviously wrong. And maybe the curve view is not in between 0 to 1, I'm not sure. Let me check. Well, it is in between 0 to 1. And curve view. So I thought I could use, but seems like UV sample is using a distance instead of the actual UV. I'm not sure. I'm not really sure. What if I change this to 1.0? Okay, now it doesn't change the positions. Now that's a problem. If I change to 0, if I change to -1, well, okay. Now that's a bit strange. Maybe I'm using the parameter in the wrong way. What if I change this to UV, and what if I change this to P? Well, if anyone know how to use this UV sample in the right way, well, I guess this is wrong. Will be great. What if I change this value? Well, this also changes the value. Now that's, well, let's not do this way. If we copy the whole network and replace the first and add node with the primary lines point, would it work? If we copy the whole network and then replace the first add node with the primary lines points, oh, I see. Yeah, I think it works. Yes, I think it works. So in that case, after we have created the line, And yeah, replacing this with other values for the next step. In that case, maybe we could use a for loop for each loop with the for each count node. Let's try that. Let's try with that. Well, I might also need to feedback the loop. Let's see how we can do it. For each count, for each number, set it to 2. And the merge each iteration is fine, but for this one, I might want to fetch the feedback. Okay. Now connect this one to, or not. So this was the geometry, so I think connecting this one is okay. And then the first point that I get is this one, so I can connect right here. Right. Now going down, and what I can use is what I can go, maybe right here is fine, probably, and go right here. Okay, now next thing I should do is on the second iterations I am going to get a curve instead of the point, so let's change this to single pass to check. And from the second iteration of the for each loop, I am getting this. Wait, maybe not. Wait, doesn't fetch feedback. Fetch piece, fetch meta. Well, fetch input is not obviously a correct things, but I wanted to have the feedback value connected to the end. Do I have to make this a for each feedback loop? I think it's a bit wrong. Okay, let me reopen this file to see if I'm getting some changes. Okay, well, I guess it's because I'm checking this one. Now, now it should work. I guess I cannot use a single pass for a feedback loop. Okay, so after I have retrieved, after I've come to the second loop, I can pick some of the point from the primitive. Well, what I'm just going to do is to just use point wrangle, and just pick random points out of those primitives. That will be the easiest way to do. And I am only going to pick the point if the number of the point endpoints 0 is more than 1, then I'm going to in this case remove the points that I don't need. So float, if there's only 1 point, I don't need to remove it. That's the point. If rand at p some threshold Then remove point. Okay. Right, now I can delete the primitive to show only the points. Now there's too much points right now. Maybe I can count the number of points that I need. Well, for that, I think I need to use detail. And loop through all the points. So say int pt count is chi, and say I only need 5 points for the next iterations, and then I don't need to go through all the points. I just need to loop through the number of points that I need. Create the random numbers again. And this time I'm going to create an integer value as an index. This time I cannot use p, but instead I have to use I multiplied by some seed value, so let's just make this constant. And multiply by n points, which was going to be the total number of points, and that will be the index by, also maybe I need to floor this value. Then I can add a point as a new point at this index. And everything else I can just remove it. So let's set some groups to prevent deleting this point group point. So set point group start, and then pt1. Okay, and the other point that I don't need, I can just delete it using another delete. So I want to delete this point without the start. Wait, that looks too much. Okay. So starting from 1,7. Okay, I think I have created for 5 points. Now I am not deleting the start points, obviously, somehow. Let me check the geometry spreadsheet. Going to the start, there's still 5 points. Wait, let me delete the points first. Okay, so alright, now this works. Okay, so I am left out with the start, but for this add node I also need to set the group start group. point start. Okay, and finally I can bring this to right here to set it as a start. And I think I also need to delete the start attribute, start detail attribute. And that start attribute has to be array now because I have multiple points. And currently I can only store one single point on the npt detail value. Now it's going to be a bit more complex. Ugh. Well, maybe I can do one more for each loop to make my life easier. Maybe I'll do that. Okay, so to do that, currently I have 5 points, right? So I can do for each point. Obviously, the calculation time will cost a bit more, but this is the easiest way that I could think of. So connect it right here, then go right here and right here. Now, wow, I am not sure if this is what we were looking for. But somehow we got some values. But somehow it's not changing, it's not animated. I think it's cached again, right? Now, in terms of making an animation, I think I have to start those points which is on top of the primitive after the primary primitive has been made. So I think I gotta deal with some Vex functions right here when to start each point animation. Alright, to do that won't be the best way, but let me just make sure that what I have done right here looks if this is correct or not. So to check that out, I am going to reduce the number of points that I'm going to make first. Let's set it to 2 for now for this one, and let's also reduce the number of lines by controlling the threshold. Okay. Now what is happening here? Okay, so let me just change this to a first loop. Okay, so it looks like this, starting from this point, right? And on the second loop, right here, we are seeing okay, I think I need to also change the end numbers right here, because I am picking the same numbers over and over again for each iterations. So to change that, I need to change this seed value for the random value right here. Okay, so to change that, I think I need to connect to the detail iteration value, the for each iteration value from 2 for each loop. Let me create a metadata for this one. Nope. And connect it right here. So now I can access to the 2 iteration value from detail of the metadata, one from the second input, one from the third input, and then I can use it for this rand. So I'm going to add it, multiply by some constant value, add it by some constant value. We'll be able to create a bit more randomized curve network. And as I have told you, the curves are colliding to each other, so might not look that pretty, but it is what it's doing. Yeah, I think it's what it's supposed to do. Okay, now is the timing. Now is the time. Set the timing when to start the second curve network to grow. Well, we can control that by setting some attribute for each primitive, maybe with an ID for this loop, this first loop, with the number of iterations as a primitive ID. Okay, so right after I have created the geometry, I can use primitive wrangle. And connect with this metadata to the second input, let's say ID, and I'm going to apply the ID for the primitive, retrieve from the detail of the metadata for the first loop iteration, and if we exit the loop, we are now having the primitive for ID1 and ID0. So ID0 is the primary polyline and the ID1 is the secondary polyline, and we want to grow the second polyline right after the primary line has stopped growth. And we could do that right here using the function that I copied from the AltForce forum. And where is that? I think I lost that page. Well, you can search for this at just prim lengths. Now let's try to do that. Now what we can do, first we need to know how many IDs out there. What's the maximum ID for the primitive? So I am going to use attribute promote. Well, we know that there is only 2 IDs, but let's say we want to increase the ID numbers by increase the iterations right here. We could also do that. So just in case we want to change that, we are going to make it a bit more procedural. Go into the primitive and set the detail, and I'm going to look through the ID, and I'm going to look at the maximum value. Change the name to ID max. Now the maximum should be 1 because there's only 2. Now inside the primitive wrangle, I can first access to this maximum ID. And also retrieve the current ID. And we can calculate the division and get it as a float value. So float current ID is equal to ID divided by float of ID max. So the value will always going to be in between 0 to 1, even though how many numbers you specify right here. Okay, so based on that information, we can combine it with this frame values, which is if the frame is equal to 1, it's close to 0, and if it's at the end, it will be 1. And in this case, we want to finish the first primary polyline to stop growing at frame 50, and then the second one start from 50 to 100. Okay, so let's try to do that using this adjust prim length functions. Now we could still use this. but we need the conditions. Maybe we could use a fit for CID. Wait, let me see. Let me think. Okay. Well, we know that there's two values right here, right? And the value 2 is the actually ID max plus 1. So what we can do, CHF, I'm going to create it as a variable right here and replace this with variable. And first I'm going to divide this by a ID max plus 1. Right now and wait, and also let me think. So this, for the second ID, I want to start it from when it gets to 0.5, when the f gets to 0.5, right? So and that is when the CID is equal to 1, right? But that is actually, maybe I should divide it like this, plus 1. So I have a value in between 0 to 0.5, right? Okay, now I can use this value to remap this f somehow. Let's name this NF and fit CID. So, and that is in between 0 to 1. And what I want to do is to convert it into a value in between. Oh wait, maybe not. Let me think. Let me write in the sketch. Okay, so I have a 0 from 0.5, which goes from 0 to 5. 0.5 to 1.5. Okay. Right. Okay. Now. Okay. I think I got it. So fit CID, which is from the current let me just try with the first primary line, okay? So this, when the CID is equal to from 0 to 0.5, and I want to convert it to 0 to 1. So in that case, what I can do is to fit CID, which is from 0 to 0.5 to 0.0 to 0.1. So that's what I want to do for the first one. So I'm gonna make it a bit manually and try to convert it into more flexible equations later. Now for this second point, what I'm gonna do is to convert the value in between 0.5 to, wait, this must be f. This should be f. And from 0.0 to 1.0. And what I should do is to replace these sources with the CID so that I can use this as a single equations, right? And now I'm starting to get what I want. So this should be CID, right? And this one should be CID plus a BPP 1.0 divided by float ID max plus 1. Does it make sense? Okay, let me check. So let's think that when the CID is equal to 0, okay, which means that's the primary number, primary polyline. So if this is 0, then this will be 0, this will be 0 plus 1 divided by 2, so 0.5, so that's correct. Let's look at the second primitive. If it's second primitive, then the value is CID is equal to 0.5, so that this will be 0.5, and this will be 0.5, 0.5 plus 1 divided by 2, so that's 1, so that seems correct. But let's also think about if the ID max is equal to 2, so meaning there's 3 versions. In that case, NF3 will be fit F. It starts from 0.66 to 0.9999, which is kind of equal to 0. And compare that to. In that case, let's see if this still works. So CID will be 2 divided by 3. Is that 1 2 1 1 0 1 2 2 divided by wait, number of 2 divided by 4. Is that it? Okay, that seems wrong. ID max, no, 2 divided by 3, that's fine. So that is 0.66, so that's correct. And 0.66 plus ID max, this will be 3, so 1 divided by 3 is 0.333, so 0.66 plus 0.33 is equal to 1. Okay, so it looks correct. So I guess this should work. Now what I need to do is to place F instead of place NF instead of F. Now I think I also need to provide some more informations. What if the CID is 2? Okay, so we need to think if the CID is out of the range of the sources. Well, let's just test if this works at this time. Okay, so 50. Alright, seems like it's working. So we have finished the first loop and start to go to the second loop, second polyline. Yeah, it is working. Now, I wouldn't say it's that pretty, but at least the code is working as I expected, I think. Now if I increase the values, there should be 3 iterations for the animations. Let's check. Well, visual wise doesn't look that pretty, but the logic explained here might be useful for some cases. I hope. Okay, okie dokie. Let's say make animation. And this should still work if the count is equal to 1, which was the original animations that I wanted to create. Alrighty, yeah, So it became more flexible to use multiple options and became really complex now. Sorry for that. There might be a better way to do that, but I'm writing while I'm thinking, so it became really ugly in terms of the network. Well, I hope you are okay with this. Oh, you don't have to feel guilty about this. I'm really enjoying it, making this on live. I'm really enjoying it. So I really appreciate all of you guys' comments. Really thankful for that. Okay, so whoops. Now, yeah, some errors, crashing errors. I'm glad I saved it. Let me check. Okay, well, since it crashed, let me just end it right here. I am going to upload the file that I have created. It should be inside a temporal folder. Okay, well, thank you very much, all of you guys, for watching. Appreciate it, and thank you all for the comment. I really like those comments with those questions, so that I can try out many things during the live. I really enjoyed it. So I'll see you next week as well. If you have time, I'll be appreciated if you could join us again. I'll try to find out some different topic. And I'm gonna do the live at the same time next week on Wednesday, 9 p.m. in Japan time. Several different times on different regions. Okay. So yeah, see you all, and thank you very much, and hope to see you next week. Goodbye. Good night.